In this video, I will talk about the work done by a varying force. The force is not constant. So, if the force is not constant, how do you calculate the work done? So, in general, we have studied the work done is equal to the force times displacement and times the cosine theta, and theta is the angle between the force and the displacement. And this formula, this equation is valid only when this force is a constant force. But now, as the displacement changes, the force also changes. Then how do you calculate the work done? We'll be talking into this problem. So here we have given a constant force, and the mass of the object is 2 kilogram, and we are applying this force onto this 2 kilogram object, and this force is now applied from x equals to 0 meter to 5 meter, or we have moved this 2 kilogram object a distance of 5 meter, and at x equals to 0, or at initially the object is at rest. And now what we have to find out, what is the amount of work done and what is the velocity of the object when it has moved x equals to 5 meter. Okay, so let's do that. So now when the work is when the force is changing, the amount of work done can be given by this formula, or by integrating the force times the displacement. So this is the instantaneous force, and that's the tiny displacement. And then now if you integrate, then that gives you the total amount of work done. And again, here I'm not using any cosine component or not using the vector here, and simply because the force and the displacement are in the same direction, or we are talking about the motion in one dimensional. So the force is a varying force which is given 5x squared plus 9x minus 5 and dx. We now need to integrate this one. So you need to keep in mind that this is the integration for x to the n into dx, which is x to the n plus 1 divided by n plus 1. So now let's use this formula to integrate each term. So you see now the power has increased by n1, so it will be 5x cubed divided by 3, again x squared divided by 2, and then minus 5 into x. So just by using this formula, we integrated this expression now, and now we have to put the limit 5 to 0. So first we will plug in 5, 3, and then we're going to plug in 5 here, 5 cubed, then 5 squared, and now 5 times x. And now we're going to plug in the limit here. So each term has x, so each term will be 0. That's the reason I put 0 here. When you do the calculation, what you get is the total amount of work done is about 296 joule. That's the total amount of work done. The second part is asking, what is the velocity at the end? If you keep pushing an object, then it will have a certain velocity at the end, and what is that velocity is. So in order to calculate the velocity, we're going to use the work energy theorem. This is the work energy theorem. The first term is the final kinetic energy. Remember, this is the final kinetic energy. Ke stands for the kinetic energy, and this is the initial kinetic energy. Again, Ke stands for the kinetic energy, and this is the formula for the kinetic energy. So the change in kinetic energy is equal to the amount of work done. and the object is starting from rest. So as the object is starting from rest, its initial velocity will be 0. So that's the initial speed, we can probably call it. So this is 0. And the work done, we already have calculated the work done, which is 295.8. Now let's plug in the other values. Have the mass is given, which is 2 kilogram. As I said here, the mass is 2 kilogram mass. So mass is given. We now finding the final velocity, Vf squared. And again, this is 0 because the initial velocity is 0, or the object is starting from rest. If we solve it, then we get the final velocity, which is 17.2 meter per second. So the thing you need to remember in this problem is we have used two very important concepts in the work done. How to calculate the work done when the force is changing or the varying force. And the second thing we used is the work energy theorem. Okay, if we know the difference in the kinetic energy, we can calculate the work done, or if we know the work done, we can calculate the velocity. So this is it for this video. Again, if you have any questions, write down your question in the comment section below. Or if you have any suggestion, any feedback, please write down your suggestion in the comment section below. And at the end, do not forget to like, share, and subscribe the channel. Thank you.